There are three ways to find the probability of an event. The relative frequency approximation, the classical approach, and the subjective approach. So let's start with the relative frequency approximation. Here we observe a procedure and count the number of times the event we're interested in occurs. For example, if we call it event A, then the calculation would look like this. The probability of event A, that's how our notation is read, is equal to, and it would be the number of times event A occurred divided by the number of times the procedure was repeated. Now, when we say observe, this doesn't mean it has to be happening right at the time you're interested in it. We could be looking at old data, and so we're not really observing something that's happening real time right then. It might be that we're going through files of information and we're looking for particular events in those files of information. So let's look at an example. Okay, during a recent year, the number of incidences of household power outage greater than 30 minutes due to weather in Lemon Grove, California was 2,663. The total number of households receiving power was 63,850. So let's think about what our sample space here is. So our sample space would be, as we go through these records, we either find an outage, the record of an outage, or there's no outage. So we're actually, for example, going through the electric company's files on all these households. So now the probability, and you would see here that obviously these are not equally likely outcomes. In fact, we don't really know what the probability of outage is versus the probability of no outage. We don't know, but our calculations will help us find that out. So the probability that there is an outage, and of course we're just looking at the ones that were greater than 30 minutes, but I won't put all that here. The probability of an outage would equal the number of times an outage occurred, as we see above, number of times the outage occurred. So going through the records, we saw that 2,663 times over the number of the times the procedure was repeated. Well, that would be going through 63,850 files, looking for records of outages. Okay, so we have this ratio of the number of times event A occurred over the total number of times the procedure was repeated. Now we can then go from there to a, for example, a decimal approximation of this, and that would be, let's see, 0.0417707, and it goes on. And so we might then want to draw a conclusion from that. And so an appropriate conclusion, if we decide to change this to a percentage, so I take my 0.041707 times 100 to convert this to a percent, and I get 4.1707%, then I could make the statement that there was a I could just say approximately 4% chance that a household in Lemon Grove had a power outage greater than 30 minutes due to weather. So we found a probability or a chance of this event occurring. Okay, now let's look at our second type, which was the classical approach. And the classical approach, I'm going to make a note here, requires equally likely outcomes. Okay, so our calculation here for event A is the probability of event A is equal to the number of ways event A can occur, number of ways event A can occur, all over the number of different simple events. And you can see why we weren't able to use the classical approach for our previous example, because this requires equally likely outcomes, and we did not have that. The probability of an outage was not equal to the probability of a non-outage. Okay, so an example of the classical approach would be a bag has 6 red marbles, 2 blue marbles, and 4 green marbles in it. What is the probability of randomly selecting a non-blue marble from the bag? So again, let's look at our sample space. In our sample space, and I'm going to abbreviate, let's see, and use colors here. How about, we'll call this red. 6 red marbles. So there's red, 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 red. Those are the 6 red marbles. We have 2 blue marbles, so there's a blue and another blue in our sample space. And finally 4 green marbles. Green, 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 green. Okay. So we want the probability of a non-blue. Okay, well that's equal to the number of ways that can occur. Well, how many ways can that occur? Non-blue, well let's count. We have 1, 2, 3, 4, 5, 6 reds, those are not blue. 7, 8, 9, 10 total that are non-blue. So 10 ways that we can reach in the bag and pull out a marble and it's not blue, divided by the number of different simple events. Well, this is our sample space, represents all our simple events. So there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 out of 12, or 10 twelfths. Now, we could be asked to leave our fractions as they are, because even though you're used to simplifying fractions, in probability that 10 over 12 really represents the situation here. There are 10 ways to draw a non-blue marble out of the 12 marbles. But we could be asked to simplify, and so this would simplify to 5, 6, or as in the last example, we could be asked to write this as a decimal approximation. And I'm going to say this is, because I'm going to round, approximately equal to 0.833. The 3's just continue repeating. So it just depends on the problem, and that should be specified how you are to notate your answer. Okay, this is the classical approach, equally likely outcomes. It's equally likely that we draw any of these marbles out of the bag. Okay, Our last approach was the subjective approach, and the subjective approach actually is an estimate using our knowledge about the subject. An estimate using knowledge about the subject. It's an educated guess. It's a method that we will not be using in this course, but examples of this would be like weather prediction. So I'll write that as an example. Weather prediction. Because you cannot just look at historical records. That might give you a little idea, but as we know, just because it rained on July 17th last year doesn't mean it's going to rain on July 17th this year. So weather forecasters have to look at many different facts and factors to determine what the percent probability of rain or thunderstorms or whatever is appropriate. And so again, this is not a method that we'll be using. Okay, finally, I want to make the statement of a very important point. Probability is a, this is another color, ratio. As you've seen how I've set the two up that we calculated, the two types we're going to be using, we set up a fraction or a ratio. That's all a ratio is a fraction. So you need to keep that in mind, that it's always represents a ratio. 10 out of 12 marbles are non-blue, or 2,663 houses out of our 63,850 houses had power outage, but it's a ratio. Always keep that in mind, and that'll help you remember a lot about probability and its calculations.